this is our shear stress. Okay, so we'll call this 10 minus 10 minus 20, 10, 20, 30, minus 30, I can go for minus 40, 40, 0, 10, 10, 20, 30, 40, minus 10, minus 20, 30, minus 40. Okay, so still the same. We draw our XY plane circle first, okay? So we know that, but before, okay, we draw our normal circle first, okay? Our 2D Mohr circle first, okay? So we have 30 over here. We have 20. Okay. Then we have a shear of 20. And then we have another shear of 20. Okay. And then we have so I'm going to label this as usual. We're going to label this as point X, point Y, and this is our point Z. Okay. So point X, the rotation is, so rotation of the element, this is clockwise. Over here is anti-clockwise. So X, the shear stress is going to rotate anti-clockwise at 30. So anti-clockwise is below. This is our X. And over here, this is our Y. Okay, so immediately we can construct a straight line. Okay, so when intersect, we know that over here, this is our 0 or center of a circle. Okay, so immediately you can calculate your stress average, which is the center of the circle. So it's 30 plus by minus 20 divided by 2 is equal to 5 megapascal. That's why the y-intercept is at 5. Okay, so this is the center of circle. Next, we're going to calculate the radius of circle. So our tau max is equal to, so you square root the whole thing, so it's 20 squared or 25 squared plus by 20 squared. Okay, so 10, 20, 25, yep, 25 squared. It's 32.015 megapascal. So your principal stresses, okay, I'm going to call them A and B this time. Okay, so it's 5 plus or minus 32.016. So the positive one is plus by 37.016. And then the other one is 5 minus 32.016 is equal to minus 27.016. So now we construct our Mohr circle. So this is 27, and then we go up to 37, eyeballing again, 32, okay, so this first circle that we have drawn, okay, I'm going to label down here, it belongs to the XY plane. And XY plane is known as your in plane, right? So this is your, I'll label this is your XY plane. This is known as your in plane. And as you recall, in plane means what? The surface area that's biggest in our element, okay? So over here, the next one, This one over here, this is known as our YZ plane. And this is our out of plane. And finally, we have this surface over here. This belongs to our XZ plane. And this is also out of plane. Okay. Okay. So this is standard 2D Mohr circle. Okay. So now we are going to locate point X. Okay. So point X is exactly over here. Sorry, point Z. Right? So that is point Z. Right? And why that is point Z? Because point Z got 0 normal stress and 0 what? Shear stress. Right? Point Z have 0 normal stress and 0 shear stress. So now we are going to draw another circle. But before I go on, I would like to label this as our stress A. Over here as our stress B. Okay. So I'm going to draw our next circle over there. I'm going to draw our next circle. So the next circle will be from here to here. Okay. So this circle now that I've just drawn, it belongs to the XZ plane, which is our out of plane. Okay. Now, let me do the other one first. Then I will tell you why is it labeled this way. Okay. So the third circle, right? So 2, 4. The third circle that I'm going to draw now will be from here. So 2, 4 is bigger than half. Right. So this over here belongs to your YZ plane, which is also equal to your out of plane. Okay. And then if I'm going to construct the other two smaller circle stress average, so the other two circle stress average is somewhere around there. Over here is somewhere around here. Okay, class, meet 3D Mohr circle. Okay, it's not a sphere. Okay, it's still one circle with three. Now, why? The next curious question is this: why this is known as XZ, and why this is known as YZ? Okay, right? It's interesting, right? Why? This is because it's called XZ because if you look at point X, right? Point X will go into stress A in a 2 theta P, right? 2 theta, sorry, will go to the stress A, the angle over here, right, is 2 theta P from X, okay? So this 2 theta P over here is less than 90 degrees, right? So if this is our point Z, right? The X point over here goes into stress A at less than 2 theta P. That's why we call what? XZ plane. Okay. Now let's look at the other circle. If we now focus at Y going to stress B, right, is also what? The angle is also equal to what? 2 theta P. And it's also less than what? 90 degrees. So the point going into the principal stress that is less than 90 degrees, that is how you label the plane. Are we clear? It's not difficult at all. Okay. So this is real life 3D Mohr circle. Okay. And I'll let you guys copy first. Okay. And you realize that it is not that difficult to draw, yes or no? Right? The most important, the most difficult part is your what? 2D Mohr circle. From 2D to construct 3D is so straightforward. Okay. So now, what is, as I said, our element is in 3D. 3D is in the real world. That's why we learn 3D Mohr circle. That is partly true. But can we sometimes get away with 2D Mohr circle? Okay, can we sometimes get away with 2D Mohr circle? So I'm going to show you 3 conditions. Okay, when you can just use 2D and when you cannot use 2D at all. Okay, so let's look at condition number 1. Okay, so let's look at condition number 1. Okay, so condition number 1. So we are going to again have an element okay, so we're going to follow the same transformation. Okay, so this is our stress X, stress Y, and our stress Z. And for the condition number 1, okay, stress X, hold on, let me shift this away. Condition number 1 is stress X is greater than stress Y, and then both are positive. And we're going to get stress Z is equal to 0. Okay, so now we are going to sketch the Mohr circle. Okay, now we're going to sketch the Mohr circle. So this is our normal stress. And then we have our shear stress. Okay, our shear stress. Clockwise, anti-clockwise. And on this line over here, right? So we have one line over here. We have another line over here. Okay. So this is our stress X, stress Y, and our stress Z points. Okay, line. So we know that because there's 0 shearing stress, this is our point X, point Y, and this is our point Z. Okay. So when we construct our first circle, okay, this is where it is our what? XY plane. Okay. So the XY plane over here is our what? in play. Okay, I'm going to stop over here. Good luck for tonight's term test. Okay, don't panic. 10% of the question is different from your what? From your homework. The rest is exactly the same. Are we clear? Okay, I'll see you guys tonight. Thank you. Anyone, any question from online? Anyone?